సబ్స్క్రైబ్ చేయండి. ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి.
Now we are going to discuss Rayleigh Jean'S law for radiation. This formula is explained energy distribution of radiation. Energy distribution of radiation. In this formula containing wavelength and absolute temperature. So Rayleigh Jean's developed a theory for the spectral distribution of black body radiation. Let us consider a hollow cube enclosure with perfectly reflecting walls. Let us inside the enclosure, the radiation emitted by the particle will be reflected by the walls. The radiation from the body undergo multiple reflections. So this radiation starts from this and reaches this. Then the stationary waves are produced here. The stationary waves of all wavelengths in the enclosure, the radiation is developed here. Let L is the distance between the walls of enclosure according allowed frequencies. So this is the stationary wave, then frequency is produced. So here L is the distance between the walls of enclosure according to allowed frequencies. So and C is the velocity of radiation. And lambda is the wavelength of vibration of radiation. First of all, the frequency of overtone is given by what is the frequency? Frequency nu is the C upon lambda. This formula derived from generally velocity equals to V equals to n lambda. Here n is the frequency. This equation can be written as velocity equals to nu lambda. Here velocity is the velocity of radiation C, nu lambda. Then nu equals to C upon lambda. So from this formula is derived. So then the frequency of overtone is given by nu equals to C upon lambda. But already we know that L is equals to lambda upon 2 according to frequency of overtone. L equals to lambda upon 2. Okay, then L equals to n lambda upon 2, where n equals to 1, 2, 3 and so on. Where n equals to 1 lambda upon 2, where n equals to 2 lambda upon 2, 3 n equals to 3 lambda upon 2. These are all lengths of overtones. So from this equation we have to derive the lambda is equals to 2L upon n. So this equation is substituted in this equation. Can be written as the nu equals to C upon, where lambda we substitute 2L upon n. Then nu equals to nc upon 2l, nc upon 2l. So this is the frequency. This is the frequency. Let we observe this diagram. We observe this diagram in xyz direction. XYZ direction. This is the x-axis. This is the y-axis. This is the z-axis. So this is the length along to x-axis. This is the length along to y-axis. This is the length along to z-axis. So let along to x-axis the length of wall is, so general equation is the L is the n lambda upon 2. L according to x-axis is the n suffix x lambda upon 2. Is similarly Ly equals to, according to along to y-axis, n suffix y lambda upon 2. Similarly Lz equals to nz lambda upon 2. These three are lengths along to x-axis and y-axis, z-axis. Here nx, ny, nz are number of loops. Number of loops. These are all loops. Number of loops along to x-axis and y-axis and z-axis. Okay. From this diagram, we know that cosine law. Cosine law. That means cosine law is Lx is equals to L cos alpha, because this is the L angle inclination. This is the L. This is the R. That means R is the vector. This is the alpha. This is the beta. This is the gamma. Okay. So from cosine law, Lx equals to L cos alpha, Ly equals to L cos beta, Lz equals to L cos gamma. Cos gamma. These are all cosine laws. Okay. So from these equations, we can be written as nx lambda upon 2. Lx is the L cos alpha. This equation can be written as cos alpha equals to nx lambda upon 2l. Is similarly cos beta equals to ny lambda upon 2l. Is similarly cos gamma equals to nz lambda upon 2l. So these equations derived from cosine laws. From again cosine law, from vector algebra, cos square alpha plus cos square beta plus cos square gamma equals to 1 square. We substitute these equations. That means nx lambda upon 2 whole square plus ny lambda upon 2, L means here cos alpha, all square plus nz lambda upon 2l whole square equals to 1 square. Cos alpha is equals to nx lambda upon 2l. Cos beta equals to ny lambda upon 2l. Cos gamma equals to nz lambda upon 2l. So further simplification, that is the nx whole square lambda upon 2l whole square plus ny square lambda upon 2l whole square plus nz whole square lambda upon 2l whole square is equals to 1. is equals to 1. In all terms, this is the common term. So nx whole square lambda square upon 2l 4l square plus ny square lambda square upon 4l square plus nz square lambda square upon 4l square is equals to 1. So in all terms, the common term is the lambda square upon 4l square, that equals to n square x plus n square y plus n square z is equals to 1. But spherical symmetric law is given by, this is the n square x, n square y plus n square z. That means n here n is the along to number of loops along to x axis, number of loops along to y axis, number of loops along to z axis. This value is equals to radius square, because spherical symmetric law n square x plus n square y plus n square z is equals to r square. This is the radius of square of radius of spherical enclosure. So this value is substituted in this equation, then this equation can be written as lambda square upon 4l square r square is equals to 1. So this equation can be written as r square equals to 4l square upon lambda square. Then r equals to 2l upon lambda. So this is the radius. Radius of spherical enclosure. So this equation represents a resultant vector from vector properties. Let us consider some here predictions are, let us consider the number of vibrations in two-dimensional plane. This is the x-axis, this is the y-axis, two-dimensional plane. So this is the n is the number of loops along to x-axis. Here n is the number of loops along to y-axis. So from this vector properties, n square x plus n square y is equals to n square x n square y is equals to 2l upon lambda whole square plus 2l upon lambda whole square. So this is also equal to r square, this is also equals to r square, this is also equals to r square from properties of vector, because this is the radius, this is the radius. So all are equal. So n square x, n square y, n square x equals to 2l upon lambda, n square y equals to 2l upon lambda, because here n square x is equals to r, n square y is equals to r. Similarly n square z is equals to r, but we have to take the only two-dimensional geometry. N square x plus n square y, that equals to 2l upon lambda whole square plus 2l upon lambda square. Then this equals to 2l upon lambda whole square. Okay, then the spherical enclosure is set up into xy plane as a quadrant. The area of the quadrant is given by the spherical enclosure is set up into xy plane as quadrant. So this is the xy plane, This is the xy plane. So the area of the quadrant is given by 1 upon 4 pi r square. 1 upon 4. So 1 upon 4, the area of quadrant is given by pi, where r is the 2l upon lambda whole square. So the area of quadrant is equals to 1 upon 4 pi 4l square upon lambda square. Here 4 is the cancel, remaining is the pi l square upon lambda square. This is the quadrant area. This is the area of quadrant. So this quadrant is divided into, for example, 8 divisions. That is the 2, 4, 6, 8, 2, 4, 6, 8. So this quadrant area is divided into 8 parts. Let us consider this is divided into 8 parts. 8 part means this is the quadrant. 2, 4, 6, 8. 2, 4, 6, 8. So the number of vibrations, the volume is given by F frequency equals to 1 upon 8 into volume of the sphere. So the frequency equals to 1 upon 8. What is the volume of the sphere? Volume of the sphere is 4 upon 3 pi r cube. 4 upon 3 pi r cube is F equals to, so 4 the 2 times 4 is the cancel 2 times, 2 3 are 6, 1 upon 6 pi r cube, where r is the 2l upon lambda square. This equation can be written as F equals to 1 upon 6 pi, r is the 2l upon lambda cube. So frequency equals to 1 upon 6 lambda 8 l cube upon lambda cube. This equation can be written as F equals to 1 upon 6 lambda 8 l cube upon lambda cube. So 2 and 3 times, 4 times cancel, F equals to 4 upon 3 pi l cube upon lambda cube. This is the number of vibration. The volume is given by F equals to 4 upon 3 pi l cube upon lambda cube. So then this is the frequency. The number of vibrations in positions of lambda and lambda plus d lambda is equals to df. So then this is the constant, this is also constant, this is also constant, because 4 upon 3 pi l cube d upon 1 upon lambda cube. So further simplification, df equals to 4 upon 3 pi l cube. This equation can be written as derivation of the 1 upon lambda 3 is the minus 3 lambda to the power of minus 4 d lambda. So then df equals to 3 is the cancel, minus 4 pi l cube lambda to the power of minus 4 d lambda. Then df equals to minus 4 pi l cube d lambda upon lambda to the power of 4. Here minus sign is neglected because the negative direction and also backward direction. So its negative is neglected. So df is equals to 4 pi l cube d lambda upon lambda to the power of 4. Okay, here L cube is the volume. Here L cube is the volume. So in this place we substitute the V. Then dF equals to 4 pi V d lambda upon lambda to the power of 4. So this is the number of vibrations in total section given by lambda plus d lambda. So that is the derivation of the frequency. This is the, so here we have to derive the number of vibrations in total section given by 2 into transverse vibrations in electromagnetic waves. So then dF equals to 2 times 2 into 4 pi V d lambda upon lambda to the power of 4. So this is the number of vibrations in positions of lambda and d lambda. This is the number of vibrations in total section. Total section is equals to 2 into transverse vibrations. So that is equals to dF equals to 2 into 4 pi V lambda d lambda upon lambda to the power of 4. Then total dF equals to 48 pi V d lambda upon lambda to the power of 4. This expression is equals to the total number of vibrations in the given enclosure. The total number of vibrations given enclosure. So now we have to derive the total number of vibrations per unit volume. That is equals to dF equals to the total number of vibrations. The total number of vibrations are here. So the total number of vibrations per unit volume. So unit volume is the denominator V. So 8 pi V d lambda upon lambda to the power of 4 upon V. So then dF equals to, here V is the cancel, 8 pi d lambda upon lambda to the power of 4. This is the total number of vibrations per unit volume. So this is the total number of vibrations per unit volume. Denominator, in the denominator the volume. So this is the Rayleigh Jean's law of radiation. This is the Rayleigh Jean's law of radiations. So this is equals to the number of vibrations in total enclosure. Now we have to derive the number of vibrations. The number of vibrations to average energy per mode of kT. This is the Boltzmann constant. This is the absolute temperature. The number of vibrations to average energy per mode of kT is given by so dF is equals to 8 pi d lambda upon lambda to the power of 4 kT. Okay, then we have to derive the average energy density. The average energy density of radiation. The average energy. So energy associated with wavelength d lambda is equals to 8 pi d lambda upon lambda to the power of 4 kT. So this is the Rayleigh Jean's law of radiation per energy distribution. This is the Rayleigh Jean's law of radiation energy distribution. So this equation also can be written as 8 pi kT upon lambda to the power of 4, where okay, So this is the Rayleigh Jean's law of radiation energy distribution.